very much. I just need to ask, is there anyone from ISED in the room? Okay, we'll stick with presentation A then. There's a mole. Well, I mean, at these events, we've heard from others like myself. I mean, Francois Gauthier has spoken on this, Julie Bergeron from CBC. So now you get to hear it from me too. Probably all of us know a little bit about Safety Code 6. I'll blast through just a little bit of the basic stuff. I have the angry timer in front of me. I'm sure we'll be able to fit it all in. So, I mean, as broadcasters, we know RF, but for the average citizen, it's kind of a, mythical kind of thing. We have Wi-Fi and broadcast stations. We have cellular. You've probably heard lots in the news about 5G and the concerns about that. We have groups like C4ST that are, it's a nonprofit group that attempts to educate people about the dangers of RF energy. We have headlines like this. I talked to somebody in Winnipeg, a land developer who had just bought a vacant piece of land, and then a cell tower popped up on an adjacent property, and he said, is this, should I be concerned about this? What can I do to stop this? Because I want to put these developments there, and I think it's going to devalue the land, and, so there's all those kind of things. This is probably hard to see, but I just put into Google, does 5G cause, and some of the things, the autofill things, brain cancer, hair loss, dizziness, migraines, these are the things that people are looking for. Well, it probably can. Heart palpitations, I'm having some of those. I'm a dedicated introvert up here, but I'll check in on my Apple Watch later and see how I did with the heart rate. But so, I mean, the question that everybody wants to ask, the consumer, the Joe citizen, is how do we know that we're safe? And so we have, in Canada, Health Canada has a published standard called Safety Code 6. And so that's what we're going to look at today. We'll look a little bit about just the rudimentary physics and biology. Yes, Philip. Oh, that's because I'm changing them on here and not using the clicker. I'll repeat everything I just said. It's much more effective, thank you. There we go. So we'll look at an overview of the different documentation from Health Canada and from ISED. Talk about how we, as consultants, do evaluations, whether by measurements or calculations, and then we'll look at some of the changes in the documents that ISED publishes and how that's going to impact things going forward. Okay, here's the really boring stuff that you all know. We have frequency and wavelength. So at some point, everybody is an antenna. I'm an antenna, you're an antenna, everybody's an antenna of a different length. Electromagnetic spectrum, we have the really dangerous stuff on the left side, the X-rays. That's why you wear the lead shield when you go to the dentist and they do X-rays. And then on the right side, you have the non-ionizing stuff. The difference being that the ionizing stuff, that's the thing that causes the three-eyed fish on the Simpsons, and that can cause changes at a more atomic molecular level. That's the really nasty stuff. It can actually damage your cells and alter your DNA and things like that, as opposed to the non-ionizing stuff, which the main symptoms or what's going to happen in the body is tissue heating, shocks, burns, all that kind of stuff. So the safety standard, I'll skip that. It's got a published safe limit for specific absorption capacity. So you're a in crude terms, a big bag of meat and water. How much power can you absorb safely? So they came up with, in their studies on monkeys, and I think they did some human trials too. Not sure who they used for that, but they found that at a certain level, 4 watts per kilogram, they could start to detect some of these changes. So the safety standard puts the limits at an average of 10 times lower than that, and that's where we get the uncontrolled limits for Safety Code 6. So when I say uncontrolled, the way that the safety standard defines a controlled environment is 3 parts, which are, what the levels are. So like there's been a study done, there's been calculations or whatever, so we know what kind of levels we're dealing with. 2 is the people that are going into that space know that there's that potential for exposure, and they know what they can sort of do about it. That would be the 3rd point. They can control their risk because they know, well, that's the microwave antenna, don't walk in front of it. That's the broadcast one, that's going to be the high power one, that kind of thing. We might know some of those things. The roof manager or the window washer or the HVAC technician on the rooftop, they maybe don't know that kind of stuff. And then the uncontrolled environment is basically everywhere else because the people there don't know what they don't know, kind of thing. That's hard to see. That's just a graph showing the allowable safety or RF levels at different frequencies, so that bottom of the bathtub there is kind of around the FM portion of the band, around 100 megahertz. And then at higher frequencies and at lower frequencies, the allowable power is a little bit higher. This one's going to be interesting. We have induced and contact currents. Probably some of us this year have been questioned on that from ISED, because it's something that has always been in the Safety Code 6 standard but hasn't really been measured historically, maybe at some AM sites or in certain things, but and I don't know if you can read this, but like the frequencies that we're talking about for this, these are like from almost DC up to 110 megahertz, which is the top end of the FM band. So it's something that is not really a concern for like UHF frequencies, cellular frequencies, that kind of stuff, but it definitely is in the FM range. In addition to Safety Code 6, Health Canada has this technical guide for compliance assessments, and it's got a flow chart in there saying how to do a survey, just kind of rough steps. It has some guidelines on signage, which we'll see later. And then ISED has a whole raft of documents surrounding this. First one is the signs and access control. The current version that's on their website is from 2013. That one is being reviewed right now. They had sent a proposal, proposed changes to RABC, and it's gone through a round of comments there. That was back in July. Just for a bit of perspective, the old one was like 7 pages long, including like the end page, the front page, the white space, the whatever. Like it was a thin document. Now it's 18 pages, and there's substantially more meat in there as far as the access control, so fencing, that kind of thing. And what I've said for a while to clients is, because there's always been this kind of tension where, if there's not enough information in there, it's vague. But if there's too much information, if the regulation is too defined, then it just becomes too heavy-handed for all situations. So what I've historically said is embrace gray, because you don't want the alternative, which is fences that have to keep out elephants and that sort of thing, which is as we'll see later, is kind of where this is going. But again, it's currently under review, so there's still time for public consultations and the ability for broadcasters to kind of say, well, wait a second, maybe this isn't going to work in all cases. Next one they have is GLO1, which is sort of a how to do measurement procedures. There was a change in December 2021, so just very recent. And I'll talk about a couple changes later on in that. Safety Code 6 measurement procedures, that's kind of similar to the Health Canada guideline for measurement studies. And then the last one is GLO8, and that's probably one we're sort of familiar with too, which has to do with the reporting formats for all these studies. And that one is also under review. So as far as broadcasters go, figuring out, how are we going to demonstrate compliance? We have a few different options. We have calculations, modeling, which is a little fancier version of calculations, and then there's measurements, and then sometimes it makes sense to sort of blend the two together. So calculations typically at sites where single frequency or maybe multi-frequency in the same antenna, what I say uncomplicated physical environments. So it's not like a hilltop where there's 14 different towers. I have a picture a couple slides later that would show something that would just be kind of unmanageable to do calculations for. So measurements would be more suited to those more complicated places where there's just lots of frequencies, lots of different towers. And sometimes it's good to do measurements just to be there, to be able to assess all the other things that go along with compliance, like making sure there's anti-climbs in place and making sure the fences are actually standing and, that sort of thing. So like this rooftop, that's one that, how would you go about calculating that? I mean, yes, you can go and measure the height of all the antennas because you can't rely on the licensing databases. They're inherently full of errors and fallacies and things that were removed from service years ago. Sites like this, I think this is Chetwynd, BC, where they have just a mixed bag of nuts of everything up there. So that's one that makes sense to measure. So that's when we haul out the nardometers. There's ones that have, there's probes for all different frequency ranges and different purposes. The one on the right does a better job of showing, what the contribution is from each frequency that's at the site. You can program in, the different FM signals, and it'll tell you the contribution of each one, whereas the one on the left is just going to give you a whole sum of everything there and just give you a number of the controlled environment limit. I'll skip that. Okay, so the report itself, so mentioned before, they have this GLO8 document, and that's basically the report that shows like if you did measurements, how are they performed, what device did you use, what are the results, where are the measurement points, some sort of diagram or map showing exactly where those things happened. If in a calculation study, it would include all the parameters that you used for that, the antenna patterns, hopefully enough information that somebody with that document would be able to repeat and come up with the same response or same result that you did. So it includes things like the report itself, whether it's measurements or calculations, like where's the site, what are the coordinates, what date did this thing take place, does the tower have guy wires, is there other towers within 100 meters, is it a rooftop, like things like that, just kind of basic information on the site. That's probably unreadable, but this is like parameters for all the different stations that are at a site, different frequencies in use. So as far as a broadcaster with lots of sites, how do you go about doing a sort of a company-wide compliance program? Because it's not as easy, or well, it can be, but how do you maintain all your documents, centralize things? How do you make those documents accessible to all the people who need them? Not just folks on the engineering team, but if you have a rooftop facility, or you have contractors coming to your tower to, whether it's mow grass or whatever, is there things they need to know? How would they get to them? I love this movie, Monsters, Inc. I'll know Roz. She'll ask Stanley, where's your paperwork? Or Mike, actually it is. So how do you store all this stuff? I think it's good for broadcasters to think about that, not just who needs it, who needs this information, and how would they get it. Because as we'll see later in some of the proposals for the that signage document from ISED, this is becoming a bigger thing. So it's good to start thinking about this kind of thing now. The other question I get a lot about these kind of reports is, how long are they good for? And I say until they're not, because it's only as good as the information that's in it. Unfortunately, we're not always made aware of changes to a facility. So, we don't often control who's going to be added to a tower, to a rooftop, who's going to put up something across the street. Had one where we had an FM station authorized on a cell tower, and then a condo development just shot up like 70 meters away, and it had balconies facing that cell tower. And so all of a sudden, without us really having any kind of notice, this thing just started to pop up out of the ground, and we did some calculations and determined, this is maybe not now the best spot to be at. So had to make a change. But things just kind of happen, and so we have to kind of be aware how often do we need to update these things, because ISED is going to ask for them every 7 years on license renewal. They're going to ask whenever you make a technical change, if you're increasing power, changing locations, that kind of thing. So it's good to kind of keep this in mind all the time, not just at license renewal, knowing that you might have to plan this in your engineering activities and in your budgets to maybe do the odd compliance study that you weren't necessarily planning for that year. Okay, signs. Health Canada has some guidance on this. ISED has a different guidance, so you can sort of pick one or the other. Most tend to gravitate more towards the ISED stuff, because they're really the ones that are kind of enforcing this stuff. But Health Canada has different warning levels. So like there's a warning, there's danger, caution, warning, danger. So it's just kind of an escalating notice to whoever's entering that place, what could happen here. At times I was telling people, just put a danger sign there, because if they're gonna, like, especially if it was at the base of a tower on like an anti-climb or something, if they're gonna defeat the anti-climb and go up the tower, then just say danger, don't say caution, because it's below a certain level on the ground. Like if they're gonna do something really stupid, just let them know what they're in for. This one is the one that's in the current ISED signage guide. It's I don't know, it looks a little hokey, but it works. I think ISED has been fairly flexible with the kind of signs that are posted. They're not 100% sticky on their guidance, which is kind of this, as far as size, bilingual, the number of signs that are posted. They say that they should be a sufficient number of signs, and I think the language later is visible from any angle of approach. So when in doubt, put more signs. Except, so there's this hotel that used to be in Galveston, Texas, that had signs posted in each of the guest rooms. This hotel's no longer there. It was damaged in a hurricane, but when they opened it, they said, let's put these signs up because people will inevitably want to try fishing from their balcony. And so then the people would throw their line with their lead weight, and some of them would not kind of hit the ocean. They would just kind of swing and hit and break windows in the dining room. And so then by removing all the signs, all of a sudden people didn't even get the idea to fish from their balcony anymore. So signs can be kind of a double-edged sword, I guess. If you tell somebody not to do something, it's just kind of human nature. They'll want to do it anyway. But anyways, the rules are what they are. So here's a couple of photos, names withheld. Their sign says danger, do not enter. Well, that doesn't really show that there's some sort of RF hazard. Like, what is the danger? Is there rocks that you can slip on? Is there, what? So got 8 minutes left here. Evolution of Safety Code 6 compliance reporting. So some of the things that have been happening over the years, it's probably 6 or 7 years ago now that they started to do the license renewal requests, where near the end of the year, October, November, they send you a letter saying your broadcast certificate expires next August. We need a report from you. And so there was 1 or 2 crazy years where hundreds of reports had to get generated. Now broadcasters are kind of used to this cycle of things and can now kind of plan in advance. Along with that regular reporting kind of came this emphasis on using the kind of a more unified reporting method like GL08. A few years ago, ISED started to really ask about guy anchors, knowing that RF energy coming off the antennas is going to get re-radiated down those metallic lines to the anchor points at the ground. This year, as I alluded to earlier, we started to hear questions from ISED about contact currents and induced currents. So that's more of a touch hazard or an induced current hazard. And those measurements have been required under Safety Code 6 or under the GL01 guide for measurements where the electric field is higher than 25%. So that's been in the documents for years. However, it hasn't necessarily been reported on strictly, but ISED has started to get onto that, and so that's kind of become a thing. In the most recent GL01, which was released last December, this appendix item showed up in there about measurements at cell sites. And so some of the, like the 4G and 5G sites have the ability to do beam forming and shift the RF energy where it's needed based on users that are in the vicinity of that site. And recognizing that, ISED updated this regulation to ask for measurements to basically take that into account, so that a measurement would have to include each of the different cell frequencies in use, simulating a maximum speed download on a cell phone or a laptop or something like that. But it's inherently kind of impractical to do a measurement campaign like that, where you have to measure each of these frequency bands at the same time or sequentially even. That would be a ghastly exercise. The other option which is not, I don't think, super accessible to broadcasters, would be to use features of the base station to turn up the power to the max for a short period of time. So that's something like a cell company could do when they're assessing their own sites, and not necessarily easy for broadcasters to do. So I was talking with an ISED person about these changes, and he said, well, if there's cellular frequencies there, then use calculations for the site. And I said, well, what if there's guy wires? He said, well, then you should measure the site. So that was my reaction. But I mean, it's a joke, but I mean, there's also as I said earlier, a hybrid approach to, measure the guy anchors, but then calculate everything else to avoid the messiness of trying to measure all of these cell frequencies. The other one that's under review right now, that I mentioned had gone through some review with RABC, is about the access controls and signage. So access controls being anti-climax fences. This one is a big one because the old one was not very big on details, and this one is heavy on details. Things like minimum spacings between the fences. So like barbed wire fences would no longer be an option because of the spacing requirements. They would need to be, like barbed wire would be limited to like the top of like a chain link fence. They have, what do I have here? The max separation for like a chain link style fence would be 55 millimeters, which is about 2 inches. That's like I think they measured like a standard kind of chain link thing, but that includes like the ground clearance. So all those spots where, the ground's uneven, you can imagine trying to make that, fit that would be problematic. 6 feet minimum heights. That's going to exclude the barbed wire fences, like I said before. The other difficulty being that these things would all not be grandfathered. So if you have a site that is already that is currently compliant, if these things go through as they're proposed, then those things are now all of a sudden non-compliant without the ability to get them caught up. So that's a bit of a problem for broadcasters. There's again the two main options for fencing. So wood would be like vertical slats, 105 millimeters, so like that's about 4 inches. That would be the spacing on that kind of a fence. The other big item is this notion of posting information for antenna and frequency operators. So each of them would have to post, and really running low on time here, so let's just skip forward a little bit. Things like this, a person, a contact, a phone number. Next one here shows technician's phone number, technician's office address, alternate contact, which, I mean, is good because if somebody needs to go into a space, they need to know who to contact if a transmitter needs to be turned down or something, or even just to know where can I go and not go. But, picture a loaded rooftop site. I mean, you could have an entire laundry list of licensees that have everything from microwave to broadcast to two-way up there, and you have this giant list of stuff that needs to get shared and how do you keep that updated? Who's going to do all that kind of stuff? I mean, roofs have security sign-ins, and they have leasing managers, and they have site managers, and they have, who's going to handle all this kind of stuff between those different groups in the same facility, similar for a broadcast site. So that's some of the kind of headwinds that we're at right now with Safety Code 6.